Hi, my name is Calvin Pierce, and welcome to my Comp3122 Python Data Science Assignment 4. In this assignment, I'm going to be taking you through all of the commands used, how they were used, and what I've learned throughout the assignment. So the first thing we want to do is we want to import our test.csv file. Remember, you're going to have to do this before every time you try and run the file when you load up the Colab file. If you don't, it will not work and you will have a big So just as the first things first, always put that into the Colab. And now let's get on with it. So the first thing we're going to want to do is import pandas as PD, because throughout the entire assignment we are working with pandas and you're going to need it for every single command. The second thing we want to do is we want to read that CSV file that we brought in earlier, and we want to store it inside our variable mydf. And next, we are going to show you the first 3 rows in the data frame inside of our variable mydf, which I will be mentioning just as the data frame, just because it's a little quicker, a little easier. If you notice, we only put the 3 inside of the head. It's because if you don't put a number, it'll always show the first 5 rows, and we only wanted the first 3 for the question. Next, we're going to drop the model column from our data frame. However, as you can see, right below it, conveniently, I have it already printed, or already got the output out. You can see that it's just temporary because we're not using in place and we're not using an assignment operator. So it'll drop it. We can show you that it's been dropped in this command. However, it is only temporary. However, like I said, if you want it to be permanent, you can use an assignment operator or the in-place parameter. But we already know how the in-place parameter works. So I'm going to show you the assignment operator, which is basically just saying, hey, you remember our myDataFrame variable? We are assigning the drop, which is why we have the equal sign. We are telling it to drop the model from its columns, and we are assigning it to our data frame. That way, when we load our head on the data frame again, we're taking our data frame that we loaded earlier with the test file, and we're already dropping that file, and we're going, hey, we want to show the head. There is no model here, as you can see up above, and that's how you know it's been deleted permanently. Now, we're going to want to just drop a couple of specific rows, specifically odd numbers. Something about them I don't like. So we're going to drop row 1, row 3, and row 5. We're saying axis 0 because it is not a header. And we're saying in place true. We already used the assignment operator, so I'm just going to show you the in place. And as you can see, it is permanently dropped numbers 1, 3, and 5, and we're just showing the first 4 rows to prove that. On to the next, we're going to be calculating our mean of our range column, and this is basically just the average. And the cool thing is that pandas can do everything for us. It is much smarter than us, so I like just to take advantage of it, because I would be here for the next year if it meant doing these calculations even with a calculator. And then next, we are going to want to see how many F's we have as a type in our data frame. If we look up above in this head where my mouse is, you can see our type is F for row 0. So what we're doing is we're checking in our type column here inside of our data frame if the string contains F. And basically we're storing it. We're using the assignment operator to store it inside of this fCount variable. And at the end, we're counting, hey, how many are true, which means it contains F, and how many are false. As you can see, we have 50 that have the type of F. And now, we're going to take those 50, and we're going to replace all of those F's with AAA, and we're using the assignment operator, put it into our type column. And now, if you look at our data frame head again, we're showing the first 5 columns. Remember, you can just leave that blank if you want to. It'll automatically show the first 5 rows. And bam, everything that would have been F is now AAA. Do you remember from row 0, that was type F, and is now AAA. Continuing on, now we're on to question 8. We want to get rid of our ugly little symbols around the cost, so we're going to want to get rid of these square brackets and the dollar sign. So what we're going to do is use our assignment operator, our new best friend, and we're going to say, hey, in our data frame, specifically in our cost column, we want to take the string and we want to replace this square bracket with nothing. We want to replace the dollar sign with nothing, and we want to replace this other square bracket with nothing, effectively removing them from the value. And then we're going to print out our head again, and as you can see, our cost now, instead of having those square brackets and the dollar sign, it's just the value of what was inside of them. On to question 9 now. We're going to change our cost column data type to an integer, and we're just going to display our results here by saying our data frame cost. You can see our data type down below is integer, and once again, these are all of our costs, and these are just the rows of which they're in. Question 10, we're going to calculate the average of our cost column. So as you can see here, if you remember, our pandas can do the mean, which is the average, and we have an average cost of 54.59. I'll just round up there to make it easy on myself. However, we want to take the average per continent. So what we're going to do is we're going to group our data frame by continent using the group by, and we're specifying our column that we want to group it by. You can't just do any name, we have to group by. You can do any column within the data frame, however in this case we want continent. So we're taking that and we're taking the cost in our data frame after it is already grouped by the continent, and we're just taking the average there, and it is going to display this nice little table output that can show you the continent and the average cost. Continuing on, we're going to want to show you the min cost, the maximum cost, and the standard deviation of the cost, all grouped by the continent still. However, we're going to do it on one line for efficiency, because you're doing it over and over again like we did for question 10, it gets time consuming, and with Python and Pandas you can be quick and do everything in one line, so why not do that? We're going to want to once again take our data frame, group by the continent, and we're going to take the column, and we're using the aggregate function, and we're taking the minimum, the maximum, and the standard deviation for each continent. And as you can see here, it does a nice little table for us. We got them all mapped out. Very nice, easy to understand. And furthermore, on to question 12, we're going to calculate the same things, but for all the numerical columns inside of our data frame. So I can just show you right here, just for ease of access, we're going to take all of our numerical columns. So you can see we're going to import NumPy, if you remember from our first few assignments, and we're going to just import it as NP, and we're going to take our data frame, and we want to select every data type that NumPy says is a number, so that being int or float. And the data types that have that are the ID, range, value, and cost. And next, what we're going to want to do is we're going to want to group by our continent in our data frame, and we're just going to want to do the aggregate of the min, max, and the standard deviation once again, and it'll automatically do all of those number values for you. The reason why we just did this up top with the data types is just so you could easily see what columns actually are classified as a number. On to question number 13 now. We're going to want to illustrate the mean of our columns, and we're going to want to show it in a bar graph, because who doesn't love graphs, and it's just nice, easy to understand. So we're going to have to take our matplotlib, and we're going to group by our continent in our data frame, and we're going to take the average or the mean, and we're just going to plot that right into a bar graph right here. And as you can see, it's a little hard to read, but it prints it all nice on the skinny bar graph right here. Everything labeled nice and neat for you. In question 14, we're going to count the number of each continent using our value count. That'll do everything for us. So what it does is it takes the number of columns, or rows rather, that are inside, that have the continent of North America, and it just counts it all up for us inside of this value right here. So you can see our data frame has 143 rows that are inside of North America. And if you want, we can take it all as a percentage over here in the next row. You can see, so North America being our leader with 143 takes up about 15% of our data frame. And if we want to continue, you can see all the unique columns in the continent column. So we have all of our continents all the way from Asia to Australia. And you can see the number of unique columns. We have all 7 continents. And next, we're going to take our value counts method, as shown earlier, and we're just going to want to see our cost in our data frame. So the output shows the cost on the index or the left side of our table, and the count in the right with the value on the right side. So for example, in this first one, we'll take, there's 20 items inside of our data frame that have a cost of 35. Continuing on now, what we're going to want to do is we're going to want to plot our cost from our data frame inside of a histogram. But with only about the 7-8 bars, I can't really tell whatever it shows here. It's really cluttered and it kind of looks like a box. It is really ugly. So we're going to want to split it up, and we're going to split it into 50 bars. And as you can see, you get a much better view of the data, much easier to read and understand. And as we continue, we're going to want to go to question 20, and we're going to be dealing with some of the values that are not a number. How fun. So what we're doing is we're looking inside of our zip code column, and we're checking what values are not a number, and we're just adding them up. So it'll be 0 if it is a numerical value, and it'll be 1 if it is not a number. And as you can see, we have 9 values that are not a number, and we're going to want to do the same thing for our type column. We have 2 values that are not a number, and I'll show you our entire database. Inside of our data frame, we just have those 11 values that are not a number. Continuing on to question 21 here, we're going to show you the current shape of our data frame. So you can see we have 947 rows to our 7 columns, and we're going to drop every single one that is not a number that we don't have the value for, and we're going to drop those 11 is null values as seen up above, and our shape now goes to 936. Continuing on, what we're going to do is we're going to show all the statistics of our type column. Remember, we did this with the cost. So you can see we have 50 values that have AAA as their type. If you remember, that was F that we changed earlier to AAA. And these 2 that are not a number still remain down here because we did not permanently delete them. Continuing on, instead of permanently deleting them, let's change them from not a number, and we're going to change it to XXX. Still, we'll realize it's not a number, but we're going to store that, and we're going to say in place equals true because we want to save that inside of our data frame. We don't want those not a number values, and we're just going to we're going to show you all the value counts showing even the not a number values as we did last time, and as you can see, they're not a number anymore. They're now XXX. Continuing on, I can show you our data frame. The shape, once again, it still has 947 rows in it. And we're going to drop from our type column. Remember, we had those 2 not a number values. However, we stored them as XXX now. And we're going to say in place equals true. We want to permanently drop them because we do not want to see any values that are not a number. And we're going to see our shape, and it is still 947 because they're stored as XXX. And now inside of our data frame, this is where we get to play with some of the fun data, and we're actually, instead of having 0, 1, 2, so far and so forth all the way up to 947, we're going to show, and we're going to set the index to the ID column of our data, and we're going to store that and say in place equals true, making sure that it is saved inside of our data frame. Just to show you our head, all the stuff that were in the ID column are now the index of our data frame. In going on, we're going to remove the index name of our data frame. Seeing nothing changed, just it doesn't say ID above that row now, and all the column names are there nice and organized in a line. And furthermore, we're just going to take the value of the column that has the ID of 70 right here, and as you can see, the value is in fact 24. Going on, what we're going to do now is we're going to take the index of our data frame. As you can see, it is all of our 947 values, whatever their ID was. And we're going to take our columns. You can see up ahead, we do not have the ID anymore because the index, we have the range all the way to the continent. And our shape, we now have 6 columns rather than 7 because our ID is our index. However, that's getting old. We're going to reset it back to the way it was. So we're going to say our index name equals ID, because once again we deleted that name earlier, if you remember, and we're going to reset the index saying, hey, we want to take this column and we want to give it back to the data frame the way it was in the test.csv file, and we're going to say in place equals true to save that. And you remember ID right here all the way to continent, it is back inside of our columns. You can see our index, all that good stuff. Our columns, it is back. And we take our shape again, and you can see 7 because we have 7 columns. Next, we're going to use the Scribe method, and we're going to see the statistics and fetch the value of the first row and the third column inside of our data frame. And as you can see here, that is 947. If we do our describe, you'll see, I believe it says count or something, and the value is 947. I don't have it printed out, but we use the 0 right here, and we're just using the integer location because we're working with the numbers. It's the way I found it easier. So we have 0 for the first one in the row, and we have 2 for the third column. Continuing, we want to sort the value counts of our data frame. As you can see, if you remember, we have 143 rows inside of North America, but we want it to be organized by the column alphabetically, so we're going to take that value counts and we're going to sort it by the index, ascending being true, so that we're sorting it alphabetically. If we did false, it would just go from South America all the way down to Africa, rather than the way it is now. Continuing almost to the end here, we're going to take our data frame, and we want to take the first row, the third row, the fifth row, and the seventh row, and want to show all the columns within those rows. So we're going to go and we're going to take our data frame and we're going to get the location of those rows, and we're going to say, hey, we want to see all columns, so we're going to take this colon, it's like a tongue twister there, and that is going to display all the columns for our specified rows. And now we're going to want to show the first 7 rows for our following columns, type, and continent, and we're just going to do that kind of in the reverse. We say, hey, we want every row from the very first one, 0, to our 7th row, 6, and we only want the columns that are column name type and continent, as you can see here. And on to the final question, we just want to see the value of the type that are equal to XXX. If you remember, we changed those not a number values to XXX. I have a couple questions up above. So we're going to take our data frame, we're going to get the location of everything in our data frame column type that is equal to the value XXX, or what was formerly not a number. And we're going to want to take those and we're going to want to look at what's inside the value column. And here we are below. We see the value of the types that are equal to XXX. Overall, this was a fun assignment. It was a little bit challenging, but it really is cool seeing that you can manipulate the kind of index and really customize the data and have fun with the charts, and the location using Pandas is very efficient for just finding subsets of data, say you needed for an assignment or just for an example. It is really quick and efficient and fun and easy to use, and that concludes my assignment 4.